everyone, we're going to perform the indicated operation and leave our result in trigonomic form. The first thing we want to do is write it in trigonomic form without the 12. So just looking at this, we have the first complex number, let's call Z1, that's in the numerator, and our second one is Z2. So to rewrite this, we need to find our R for this one. So our R equals absolute value of C1. That equals the square root of 1 squared plus 1 squared. That equals square root of 2. And then our angle is going to be inverse tan of 1. That's just y divided by x. And so that's going to equal pi divided by 4. So basically for our numerator, we're going to have square root of 2 times cosine of pi divided by 4 plus I times sine of pi divided by 4. And then we do the same thing for our Z2, our denominator. So basically for that one, we get our R equals absolute value of Z squared, or Z sub 2. That's a square root of 3 squared plus 1 squared. That equals 2. So we're going to have a 2 here. And then we take our inverse tan of theta, which is y divided by x. So that's 1 divided by square root of 3. And that's going to give you pi divided by 6. All right, so now we have our denominator is going to be cosine of pi divided by 6 plus I times sine of pi divided by 6. All right, now this can simplify to square root of 2 divided by 2. And now since these are both Z1 and Z2, when you're dividing these two, you subtract. So basically, we group these together and you subtract since it's a division. So that's going to be cosine of pi divided by 4 minus pi divided by 6. And then you do the same thing with this one. This is going to be plus I times sine of pi divided by 4 minus pi divided by 6. All right. And then for this, our common denominator is 12. So this is just going to end up being, when you simplify, you could just let it be 24. And cross multiply, you get 6 pi minus 4 pi, which is 2 pi divided by 24. That's going to be pi divided by 12. All right, so let's write that out. And we're going to have square root of 2 divided by 2 times cosine of pi divided by 12 plus I times sine of pi divided by 12. All right, so a lot of work just to get it into a form where now we can use the Moivre's theorem. And to do that, our n is 12, so all you do is you take our r, square root of 2 divided by 2, raise it to the power of 12. And then you're going to take a cosine, and this is going to be 12 times pi divided by 12. I'll do that. Plus I times sine of 12 times pi divided by 12. All right, let's see what we get. This is just going to be 1 divided by 64. And then we're going to have cosine of pi, these two cancel, plus I times sine of pi. Now that's in trigonomic form, and basically what it would be is 1 divided by 64. Cosine of pi is -1, and sine of pi is 0. So your final answer would actually be negative 1 divided by 64 if you need to go that far. But it says leave it in trigonomic form. This is trigonomic form right here. Thank you. Have a nice day. Bye-bye.